Electric vehicles, aka EVs, are something that people started dreaming of ever since gasoline rates began inflating. In recent years, EVs have become a new trend that is selling well throughout the whole world. But is this vision of an all-electric future truly within our grasp? Will ICE engines really cease to exist? Let's start with the second question. ICE engines, which stands for internal combustion engines, are a particular type of engine that is currently being used in almost every vehicle except a few. To run a vehicle that uses this engine, we need some kind of combustible fuel. Here comes the role of petrol, which is considered best and easy to find until a few years ago, when the increasing population began buying cars and other vehicles at a rate that was never seen before. This then resulted in petrol price inflation, since the demand was increasing at a fast pace, while extracting fuel became harder, as fossil fuel is something that takes centuries to produce. So, long story short, because of fossil fuel being limited, the ICE engines and the vehicles that need any kind of petrol to run will cease to exist, no matter if electric vehicles replace them or not. With that said, now let me answer our first question. Are we really going to be all electric? Today, EVs are no longer a novelty. With companies like Tesla, Nissan, and BMW leading the charge, EVs are becoming more accessible and popular. Governments worldwide are pushing for greener alternatives, offering incentives for EV purchases, and investing in charging infrastructure. Advancements in battery technology are at the heart of the electric revolution. Lithium-ion batteries have become more efficient, with higher energy densities and faster charging times. Researchers are also exploring solid-state batteries, which promise even greater performance and safety. The environmental benefits of EVs are clear. They produce zero tailpipe emissions, reducing air pollution and greenhouse gases. However, the production of batteries and the sourcing of raw materials like lithium and cobalt raise environmental and ethical concerns. Despite the progress, the challenges still remain. The current charging infrastructure of EVs is insufficient for widespread adoption. The fear of running out of battery power is keeping a lot of potential buyers at bay. And in opposite to gasoline, charging takes a lot of time, which again worries the buyers for wasting their precious time. More importantly, the high cost of EVs compared to traditional vehicles is a significant barrier. For an all-electric future to be truly sustainable, the electricity powering EVs must come from renewable sources like solar, wind, and hydroelectric power. Looking ahead, the future of electric mobility is promising. Autonomous electric vehicles, smart grids, and vehicle-to-grid technology are on the horizon. These innovations will not only make transportation cleaner, but also more efficient and interconnected. While electric vehicles dominate the conversation, there's another way, the hydrogen fuel cells, that offers an alternative path to a zero-emission future. Hydrogen-powered vehicles produce only water vapor as a byproduct and can be refueled quickly, which can be a great advantage against EVs unless some kind of ultra-fast charging technology develops. Companies like Toyota and Hyundai are currently investing in hydrogen technology because they seem to have seen the potential power of it. The turn to electric mobility will also have profound economic implications. The automotive industry will need to adapt. New jobs begin sprouting in battery manufacturing, charging infrastructure, and renewable energy sectors. Consumer behavior will play a crucial role in transitioning to an all-electric future. In Europe, stringent emissions regulations and urban low-emission zones are accelerating this revolution. In China, government mandates and subsidies are driving rapid EV adoption. Meanwhile, in other developing nations, the transition may be slower due to economic and infrastructural challenges. Innovation will also be the key to overcoming the challenges of an all-electric future. Breakthroughs in battery recycling, wireless charging, and energy storage solutions are on the horizon. Collaborative efforts between governments, industries, and research institutions will pave the way for a sustainable and electrified world. Public transportation is a critical component of the all-electric future. Electric buses, trams, and trains are being adopted in cities worldwide, reducing urban pollution and congestion. The transition to electric mobility also impacts rural areas. While urban centers may see rapid adoption, rural regions face unique challenges. such as longer travel distances and limited charging infrastructure. Tailored solutions like mobile charging stations and incentives for rural EV adoption will be necessary. Education and training programs will be vital in preparing the workforce for the electric future, from engineers and technicians to policymakers and consumers. Everyone will need to understand the new technologies and their implications. Universities, vocational schools, and online platforms will play a key role in this transition. Smart cities will play a pivotal role in the all-electric future. By integrating advanced technologies like IoT, AI, and big data, smart cities can optimize energy use, reduce emissions, and improve the quality of life for residents. So, is the future really all electric? Well, while there are many hurdles to overcome, the momentum is undeniable. With continued advancements in technology, supportive policies, and a collective commitment to sustainability, an all-electric future is not just a possibility, it's an inevitability. But again, maybe some other technology that is more efficient than EV will develop and turn the table?